Hello everybody, I hope your calculus learning is going well. So you know infinity come up often in derivatives, in integral, and infinite series. Many places the math use the concept of infinity. What is this infinity? Is that just a math concept? Is far from the reality? For example, space, they said the size of space is infinity, but another theory said no, size of space is not infinity, it's finite space, but distance is infinity. Well, physics knows how to reconcile this kind of things. Okay, so we talk about this infinity. Is that the real or just a game in the math, particularly in the calculus? So where we start, okay, we learn what is the area. Area is 1 by 1. It's called area 1, right? So we expand, we know rectangle area. Okay, so in elementary school we learn how to calculate the area of rectangle. Everything surrounded by straight line. The surrounded by straight line, how about triangle? How we calculate this area? So suppose this is a height h, right? And bottom is L. So we make two triangles together, right? So this is a h. So parallelogram's area, we know L times h, because what we can do is cut this and put this here, become rectangle. Good. So we're talking about this rectangle. So L times h, and triangle is half, so it's very clever, right? Like Greek mathematician did in geometry. You can calculate the area of triangle. How about circle? Then mystery come in. The pi, they don't know where it's come from, but using pi you can calculate, right? So how about those curve? Well, then we cannot use this definition or even adding pi. It's impossible. What is the area? So it's become the definition of area. How we define the area of something surrounded with a curve. Okay, so in order to keep the consistency with this, what we did is we made many rectangles and increase by making delta x small, increases number of rectangles and sums up, so become integral, right? So 0 to x fx dx. So this become the definition of area. So what do you mean we calculated the area? Well, no, this is a definition of area. It's not something you calculated out of other theory. It's just you define this integral as a definition of area. Okay, and definition has this delta x goes 0 or n goes to infinite, the infinite in it. We need to use this infinite to define the area. How about lengths? We take a ds, element of the length, and integrate a to b. Okay, the length is a to b, and ds we add this ds from a to, what is the ds? ds is dx square plus dy square. And if you want, you can make it like 1 plus dx, because derivative of y is dy dx, right? So this become 1 plus y dash square, or square, forgot, dx a to b. So this is the definition of lengths, because in elementary school you learn lengths. This is 1 inch or 1 centimeters, and you calculate and you divide this, then you get 3.5 inches or centimeters, depending on the measuring system. But this is a straight line. We never define the length of curved line. So this is the definition of length. Okay, you define that. It's any physical meaning. Well, let's do this. You have a cylinder here, right? And you have a rectangle. You put the water, right? The volume is A, B, and C. A, B, and C, right? This is all straight line. You pour this water in, right? So you know pi r square and times height is the volume according to this definition, integral, the volume definition of integral. Okay, so you calculate this, exactly match up, right? This is going to be pi r square h. So physically, you can say this old definition we learned in elementary school is same definition as the new definition using integral, using infinite concept in math. So this infinite, you can tell it's a root something here. Infinite concept is not something just a game. It's physically, it's produce something correct. Got it? Well, we can do cone, and same way you put this water in, and this, say H2 this time, okay? And this has cones, the spread ratio, okay? So this volume, how you calculate this? You put the cone this way and take this disk, right? And disk area is pi x square if this is point x. U pi x square is element, and dx from 0 to h2. Okay, but pi x square, it's not x square actually. This slope is m x square, right? Because it's height. Okay, so this is gonna be the volume of the cone. This definition of volume given by integral, which has an infinite concept in it, match up with this exactly physically. Why physically? You put the water, just put the water in, then you can tell exactly this one from A times B times C. You can tell exactly this one. If you know the M, So it's physically, it's exactly correct definition. What do you mean definition is correct? Well, you define volume using infinity concept, and that definition is going to give exact correct answer when you pour the water in. That means it's qualified as the definition of volume, right? If this ABC you pour in, it become H2 dash, then this definition is not valid because you can't use it in a science. Okay, now, well, infinite is that powerful? In science, there are a lot of infinity come up. For example, quantum mechanics predict the particle is here at X, but quantum mechanics can predict only the probability of the particle to be here by distribution function. Okay, now this distribution function come from the equation, right? Quantum mechanics equation, you solve it, then it shows the quantum existence location, most likely here, but here it's possible. Now you put this quantum into some device which has a potential wall, right? A potential wall means this, you put the quantum, say electron, and here is big negative charge. So electron moving between this wall, but energy is not high enough to go over this, right? But when you solve the equation of this electron, there is a probability that it's outside of this. So the equation was solved using the concept of the infinity, right? Do you believe that? Okay, let's find out. So the scientists tried to do some experiment, confined electron into the potential wall, then found out some amount of electron, there are many electrons here in this wall, comes out. It shifts out from this wall. That's strange. You solve the equation and it's predicted its electrons go through this. How is it possible? This is called tunneling effect. There must be a tunnel to go through. The reason is electrons' quantum existing point is given by distribution. But it's strange. This distribution function goes all the way to infinity. That means when you have electron confined, there is some possibility that you find it in another galaxy. It may be very tiny probability, but it exists based on this. Is that true? It go infinity. Every particle exists everywhere in the universe. Or maybe this equation is wrong. Somewhere it's become zero suddenly. But when you solve this equation, function goes all the way to infinity. So this function may be wrong. Maybe equation has to be changed so that sometime later it's dropped to zero. Otherwise, you have to say every electron exists everywhere at a certain probability, right? So it's funny things happen. You can't have everything existing in the space in every infinite distance. But there's no way to verify that unless we put the detector on the other galaxy and wait for this electron to sometimes shows up suddenly, boom, here. Okay? Interesting? So in science, infinity is a lot of problem. Infinity in calculus solve a lot of problem. Would actually help to define many things, but science still has a lot of problem. For example, you flip the coin and head or tail. We say, yeah, it's 1/2, 50-50 chance, right? But be careful when you say this, because of 50-50 chance, if you flip it infinite times, okay? Because it could be head, 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 million times, then head and tail randomly show up, but tail is somewhat more than head, and if you add this up, about 50%. But this million times you show up, the head show up, what is this all about? It's possible, right? So what you are saying is infinite times, if you do this, it's become 50-50. But before you reach infinite times, it could be 90% head and 10% tail, and suddenly someday it's change. And if you keep flipping, it goes to infinite 50%, but it's shift again 90% tail and 10% head. You never know. But then how do you deal with this? You can't tell it's a 50-50 chance unless it's infinite times, right? If you flip, definitely it's head or tail. Okay, so you repeat that 1,000 times, not enough. It could be 65% and 35%, right? Who knows? So infinite cause a lot of trouble in the real physics. When you say infinite in the physical things, there's a lot of controversy shows up. The calculus, almost everything's nicely rounded to be exact correct, because mathematician doesn't like controversy. They solve every controversy to down to the bottom and nicely fit everything logically correct. Okay, so that's what you're learning, calculus. So you are learning a very refined theory using infinite. Okay, there are a lot of questions still the mathematician doesn't know. For example, pi is 1 point. Forgot. as yeah, something like that. Now you look at this one, how many 5 you see, how many 9 you see. So number of 5 and number of 9 or 1, whatever, are they same in pi? How about square root of 2? Unfortunately, we don't know. Even mathematician cannot tell. It just keep having this randomly. So what is the definition of random? If you did this, say, million times, calculate, and the 5 is like, if it's uniform chance, is 10% of time, right? But 9 shows up, say, 20%, and the one others show up less than 10%. So what can you tell? You did million digit. Not enough, right? You have to do infinite times. Otherwise, you cannot say how many 5 shows up this irrational number, square root of 2. So we don't even know they show up at even 10%, the even uniform rate of each number, 0, 2, 0, 1, 2, to 9. Okay. So one mathematician from Russia said, well, there is a chance if you convert this to by ASCII. ASCII is convert this into alphabet. Right? Then you may find the series of number. It happen to be hello, how are you? Convert the number to ASCII code. I'm God. Something like that. You have a chance to find this kind of sentence embedded into this number, right? So he continued, if you have a chance to have this kind of ridiculous message in the number, there is also a chance that entire Shakespeare's book shows up. Very little chance, but who knows? Right? Because the number go randomly infinite times, there is a chance. Okay, is that true? Well, we don't have a conclusion. We don't have any math proof. So at least this is outside of calculus, so you don't have to worry. Inside calculus infinity is nicely contained, so everything's nicely explained, proved stuff. There is some loose end is in infinite series. In another video I explained this, so you can look at that. Okay, that's all today. If you think this story is interesting to learn the calculus, please subscribe and wait for the next video.